In this problem, it says to consider the apportionment of 60 doctors for a physician's organization. The apportionment using Hamilton's method is shown in the table below. So that's what we have here. They used Hamilton's method. And we want to determine if the Alabama paradox occurs using Hamilton's method if the number of doctors is increased from 60 to 61. So what we're looking for is, what if we redo this whole thing and we see that one of the clinics actually winds up losing a doctor even though they added the total of one to the total number of doctors. So let's see if that happens here. It can happen with Hamilton's method. It's odd for it to happen, but it can happen. So let's redo this according to Hamilton's method. So first thing I'm going to do is figure out what the standard divisor is. And to do that, I'm going to take the total number of patients, which is 3,221, and I divide that by 61, which is the number of doctors. And so this gives me approximately 52.8. So that's what I'm going to use for my standard divisor. They didn't say how to round the standard divisor, so I looked at what I got, and I got 52.80 something. So I just went ahead and rounded to 52.8. So now I'm going to take each of the number of patients for each clinic and divide that by the standard divisor. So the first thing I'm going to do is take 738, divide by 52.8, and what does this give me? 13.977. And I'm rounding that to 3 places because that gives me enough places that if I have 2 that are close, usually that'll be enough to tell the difference between the 2. So now I'm going to go through and do that for each of the others. Next one is 603. Again, divide by 52.8. And this time I get 11.420. So I'll go ahead and do that for the others. Okay, so now I have the standard quota for each of the clinics. And I'm going to take off the decimal portion. So 13.977 just becomes 13, 11.420 becomes just 11, and so on. And I'm going to add those up, and that adds up to 57. So we have 61 doctors to deal out to all of these clinics, and we already have 57 of them assigned. So that means that there's 4 left over. So who gets those 4 doctors? I'm going to give 1 to each clinic that has the largest decimal portion. So I'm looking at now the 977, the 420, 947, 818, and 841. And of those, I have 5. I need to give out to 4 of them, and this is the lowest. So this is the one that doesn't get an extra. So I'm going to add 1 to these 4. And now we're up to 14. This stayed at 11. This is up to 11. This is up to 12. And this is up to 13. So those are the numbers I'm going to put in here. And you can double check, add that up. Should add up to 61. Now, did the Alabama paradox occur? First, when we had 60 doctors, A had 14 doctors, and they still have 14 doctors. So that's fine. We only had 1 to give out. Not everybody gets a new one. B had 11. Still has 11, looks good. C had 11, still has 11, that's totally fine. D had 11, went up to 12, that's cool. And E had 13 and stayed at 13, and that's totally fine. So what I'm looking for is something like if E had 13 originally and then went to 12. Then we would say the Alabama paradox occurred. But since no clinic suffers a loss, then the Alabama paradox does not occur. And that's how you do that problem.